Welcome to our show, Future Trends. Today, unveiling the universe's mightiest force, the strongest magnetic field ever created. Have you ever wondered what's happening in the universe? Especially, what forces are at play when we think far beyond our Earth? Today, we're taking you on a journey that offers deep insights into the physical phenomena right after the Big Bang. It's about creating the strongest magnetic field in the universe, recently achieved by scientists in a particle accelerator in the USA. But how strong is this magnetic field, and what does it mean for our understanding of the cosmos? Imagine creating a magnetic field stronger than anything we've known before, 1 trillion Gauss strong. For comparison, the Earth's magnetic field is about 0.5 Gauss. Physicists have achieved just that by colliding heavy ions like gold or lead nuclei in the relativistic heavy ion collider. These collisions produce a quark-gluon plasma, a kind of primordial soup, from which everything in the cosmos originated. But why is this important? Shortly after the Big Bang, around 13.8 billion years ago, this primordial soup existed, where quarks and gluons flew freely before becoming the atoms that everything is made of today. By recreating these conditions, scientists can study fundamental properties of matter under extreme conditions. What's special about this experiment, however, is not just the creation of the plasma but also the discovery that it generates an extremely strong magnetic field. This field is so powerful that it is 1,000 times stronger than the fields of magnetars, extremely dense neutron stars previously considered the strongest magnets in the cosmos. But this record-breaking field disappears as quickly as it appears within about 100 quadrillionths of a second. What does the creation of such a strong magnetic field mean for our understanding of the universe? This discovery not only gives us insight into the conditions immediately after the Big Bang but also into how quarks and gluons interact under extreme conditions. The high conductivity of the quark-gluon plasma and its interaction with strong magnetic fields could provide new insights into the structure of matter and the forces that acted in the early universe. But now we want to hear from you. What do you think about these fascinating discoveries? How does it change your view of the universe and the physical forces at play? Share your thoughts in the comments below. And if you enjoyed this video, don't forget to subscribe to our channel for more exciting insights into the world of science and technology. See you next time.